Hi, today we're going to talk about how to name triangles. We're going to name triangles in two different ways. We're going to name it according to its angle measures, and then we're also going to name it according to its side measures. Let's first start with an acute triangle. An acute triangle is going to look like this. This is one example. In an acute triangle, all angles are acute. And if all angles are acute, that means we know from previous unit that acute means it's going to be between 0 and 90. So for an acute triangle, every single one of these angles are going to be an acute angle. So all of these angles are going to be between 0 and 90. An obtuse triangle, we think about our obtuse angles. If it's an obtuse triangle, that means we're going to have one of those angles be an obtuse angle. So one angle is going to be obtuse, and if it's obtuse, that means it's going to be between 90 and 180. Again, a review from our previous unit. In order for the triangle to be obtuse, we have to have one obtuse angle. We're never going to have more than one. We're only going to have exactly one obtuse angle. A right triangle is a triangle that's going to have a right angle. So one angle is a right angle, which means, what's that say? One angle is going to be equal to 90 degrees. A right angle is going to be a 90-degree angle. Equal angular, if it's equal angular, that means equal, the same. All three angles have the exact same measure. So in an equal angular triangle, all angles are congruent. They are all the same. Now we also know what the measure of each of those angles are going to be. If it's equal angular, we have three congruent angles. We know that all three angles in a triangle add up to 180. So if I divide that into three equal pieces, each angle is going to be 60 degrees. So not only are all the angles congruent, all angles equal 60 degrees. So those are how we can name a triangle according to its angle measure. It's either going to be acute, obtuse, right, or equal angular. Then we're going to name it by its side lengths. We have three different kinds of triangles according to the side: scalene, isosceles, and equilateral. If it's scalene, we're going to have three different side lengths. So in a scalene triangle, all sides are different. In an isosceles triangle, we're going to have two of our three sides being congruent. And these are actually going to be called the legs of the triangle. The two sides that are congruent are the legs. The one side that is not congruent is going to be the base. When you have an isosceles triangle, if the legs are congruent, then these base angles are congruent. And last, that means that this is going to be the vertex angle. So isosceles is complicated in the fact that with isosceles triangles, we have a lot of vocab words that are connected to it. But by the definition, an isosceles triangle is when we have two sides that are congruent. And last is the equilateral. If it's an equilateral triangle, all sides are congruent. So scalene, there's no congruent sides. Isosceles, you have two congruent sides, and equilateral, you have three congruent sides. Let's make a quick note here. Let's compare these two categories. If it's equiangular, it also has to be equilateral. These two pieces go hand in hand. It can't be equilateral without being equiangular, and it can't be equiangular without being equilateral. So if you have one, you have the other. Equiangular. All right, so let's go ahead and use this information to solve. Or actually, we're going to start by classifying. So we have our triangle. We want to classify the triangle by its side lengths and angle measures. When we are classifying or naming a triangle, we can always name it in two ways, one by the sides and one by the angles, depending on what we're given. If we're only given side lengths, then we can only classify by sides. If we're only given angles, we can only classify by angles. But here, I have multiple pieces of information. I see an 8, I see a 7, I see a 6. So this triangle is going to be a scalene triangle. I know that because all sides are different. Then I name it according to the angle measure. This is 112. I don't know what this angle is, and I don't know what this angle is, but it really doesn't matter. Because I have one angle that is between 90 and 180, I'm going to say this is going to be an obtuse triangle because you have one obtuse angle. So again, every triangle, if you're given the right amount of information, can be named in two different ways. What you want to make sure that you concentrate on, knowing which words go with angles and which words go with side measures. We don't want to confuse those two. So our next one, the perimeter of a triangle is 122 if the three sides of the triangle are 15x minus 18, 6x plus 14, and 8x plus 10. Solve for x and classify the triangle by its sides. So I look at the information I'm given. One, I know the perimeter of the triangle. We think about what we have. A triangle, we don't know what kind of triangle it is, so we just draw a generic triangle. Perimeter, we find the perimeter by adding up all the sides. So we've got one side, two sides, three sides. To find that perimeter, I have to add up all of the sides around it in order to find that perimeter. Well, we are then told that the three-sided triangle are 15x minus 18, 6x plus 14, and 8x plus 10. So we're going to label those given sides. 15x minus 18, it doesn't matter which one you put where, 6x plus 14, and 8x plus 10. We just said to find the perimeter, we add up all three sides. So we're going to add up all of them. 15x minus 18 plus 6x plus 14 plus 8x plus 10 equals that perimeter of 122. From here, we're going to combine like terms. So 15 plus 6 plus 8 is going to give us 29x. Negative 18, positive 14, positive 10 gives us a positive 6. We just simplified the left-hand side. Now we're going to solve by moving those over. 29x is equal to 116. We divide by 29, and we find that x is going to be equal to 4. Now we're not done yet because the question asked us to classify the triangle by its side lengths. So what we have to do is we have to plug 4 back in here. So 15 times 4 minus 18. This side length is going to be 42. 6 times 4 plus 14. This side is going to be 38. 8 times 4 plus 10. This side is going to be 42. So I look at my three side lengths, and that means that this is going to be an isosceles triangle because 2 of the 3 sides are congruent. All right, let's go ahead and turn over to the back side. Our next example is find x in all angle measures and then classify it by its angles. So we were just looking at perimeter. Perimeter is adding up side lengths. We have the 3 angles. The one thing that you don't want to forget is that all 3 angles in a triangle add up to 180 is correct. So if I want to solve this, we add our 3 angles, 9x minus 5 plus 3x plus 29 plus 10x plus 2 is equal to 180. We combine our like terms because we're all on the same side of x, so that gives us 22x. Negative 5, 29, 2 gives us a positive 26 equals 180. We move our 26 over. 22x is equal to 154. Divide by 22, and we find that x is going to be equal to 7. And we're not done. We want to classify by its angle measures. So now I have to take that and plug it in. So 9 times 7 minus 5, this is going to be 58 degrees. 3 times 7 plus 29, this is going to be 50 degrees. And 10 times 7 plus 2, this is going to be 72 degrees. So I look at the 3 different angle measures. This is going to be an acute triangle because all angles are acute. And when you name it, you do have to justify your answer always. Tell me why you made that conclusion. So how did you conclude that it was acute? I knew it was acute because all of the angles were acute. All right, our last problem. Solve for x and find the perimeter. As I look through this diagram, there's a couple of things that should jump out. One, I see these 2 indicators. This tells me that it's an isosceles triangle. That's going to come into play. But if we want to, we can go ahead and just start by solving for x. We know all 3 angles add up to 180, so I do 180 minus 62 minus 56, and we find that x is equal to 62. You actually didn't have to do any of that work, because if you remember when we discussed isosceles, if this is congruent to that, that means that our base angles are also going to be congruent. So if this is 62, this is going to be 62. And when I look at that indicator, if this is 10, this is 10. So my perimeter is 10 plus 10 plus 8, giving me a perimeter of 28. Okay, and that is the end of our video today.